This video is for section 6-3, linear functions and direct variation. A function such as this one, the set of ordered pairs, such that y equals negative 5x plus 3, which has a polynomial of degree 1, is called a linear function. You notice that the exponent on x is a 1, so it's degree 1. This is called a linear function. The graph is a straight line with a slope of negative 5 and a y-intercept of 3. If we know the slope of a line and we know the y-intercept, we can make the graph. Start by graphing the y-intercept, a dot at 3, and then measure off the slope. Negative 5 is the same thing as the ratio, negative 5 over 1. So go down 5 units and right 1 unit. And this downhill line is the graph of that linear function. In general, a function f is a linear function provided there exist real numbers b and m, such that for every x in the domain, function f of x equals mx plus b. This is the slope-intercept form of a linear equation that we looked at in an earlier chapter. Do you remember y equals mx plus b? This has the exact same format as that. The graph is a straight line having slope m and intersects the vertical axis at the point 0, b. That's called the y-intercept. Here's an example problem that uses a linear function. The table shows the weight x in pounds of an object on Earth and its weight y on Mars. So when an object is 50 pounds on Earth, it only weighs 20 pounds on Mars. When an object is 100 pounds on Earth, it only weighs 40 pounds on Mars, and so on. The last column shows the ratio of y divided by x. 20 divided by 50 is the decimal 0.4. 40 divided by 100 is the decimal 0.4. When you divide the other values, you also get the decimal 0.4. The ratio y over x is the same every time. And if you take that ratio and solve it for y by multiplying by x on both sides, the x would move over to the right side, creating the equation y equals 0.4x. This has the form y equals mx, which is like y equals mx plus b if the b was a 0 here on the end. This type of linear function is called a direct variation. A direct variation is a linear function where the y-intercept value is 0. We say y varies directly as x, or maybe you've heard the phrase directly proportional to. Y is directly proportional to x. The variable m means slope when describing a line, but when we're discussing direct variation, the m is referred to as the constant of variation. If two ordered pairs in a direct variation are x1, y1, and x2, y2, then this proportion is true. The y1 compared to the x1 will be equal to the y2 compared to the x2. We saw that in our chart comparing the weights on Earth and Mars. Every comparison of y to x was equal. They were all 0.4. An equality of ratios, such as this equation, is called a proportion. And you will have solved proportions before in middle school and in Algebra 1 class. Terms in the different positions in a proportion have names. The upper left term and the lower right term are called the extremes. The lower left term and the upper right term are called the means. Here's a review of a theorem from Algebra 1 class. In a proportion, the product of the means equals the product of the extremes, meaning you can multiply the number in the top left position by the number in the bottom right position, and you know that will be equal to the x1 times the y2. This is the cross-multiplying technique that you've probably used to solve proportions. Let's try an example. If property tax varies directly as assessed valuation, determine the tax on a house assessed at $14,000 in a community where a tax of $382.50 is levied on a property assessed at $9,000. Because we're told that tax and the assessed value of a home varies directly, we can create a proportion to match up facts in this problem. A tax of $382.50 is paired with a house that's assessed at $9,000. That will be equal to the amount of tax on a house that's assessed at $14,000. This is a proportion and it compares tax to the assessed value of a home. The $382.50 goes with the $9,000 home. The X amount of tax goes with the $14,000 home. We can solve this using the theorem. The product of the means equals the product of the extremes. That means the cross-multiply technique. The 9,000 times X is equal to the $382.50 times the 14,000. Next, divide by the 9,000 to get the X alone. X equals $595. X is the amount of property tax, so we need to put a dollar sign with that. If a home is assessed at $14,000, the property owner pays $595 in property tax. There is another way of solving this same problem. Because we're told tax varies directly as assessed value, we know that the equation y equals m times x will fit the situation. Because any problem involving direct variation has this basic equation where the plus b is just a zero. We can take known information, substitute it into the equation to solve for m, which is our constant of variation. If we let the letter y be the property tax, then we can fill in $382.50, and for x, fill in the assessed value of the house, $9,000. Then divide by 9,000 to solve for m. $382.50 divided by 9,000 is 0.0425. Now that we know the value of m, we can model our situation. Y equals 0.0425 times x. The letter y is the amount of tax, so we can find the amount of tax on a $14,000 house by substituting 14,000 in for the letter x. When you multiply these together, you get the answer $595. This technique relies upon creating a model following the direct variation formula. This other technique involves using a proportion to get the answer. Here's another example problem. The rate of consumption of the oxidizer used in a rocket engine is directly proportional to the rate of consumption of the fuel. If an engine is consuming 2 pounds per second of fuel and 5.6 pounds per second of oxidizer, what would be the rate of consumption of the fuel when the engine consumes the oxidizer at a rate of 7 pounds per second? One way to solve the problem is with the direct variation formula, y equals m times x. Let's use the letter x to be the amount of oxidizer and the letter y to be the amount of fuel. One of the sentences tells us how much fuel is used for a certain amount of oxidizer. We're told we use 2 pounds of fuel when 5.6 pounds of nitric acid oxidizer are used. We can solve for m by dividing by 5.6. M turns out to equal 0.357. So our equation is y equals 0.357 times x. Next, we can calculate the amount of fuel when 7 pounds of oxidizer are used. The answer is 2.5 pounds per second. This problem could have been solved with proportions. 2 pounds of fuel is used when 5.6 pounds of nitric acid oxidizer are used. So how much fuel is used with 7 pounds of oxidizer? You can solve this with the cross multiplication technique. 5.6 times x is equal to 2 times 7. Divide both sides by 5.6 and you'll get 2.5 pounds per second. Here's one more example. Some ordered pairs are given. Question A, is there a linear function containing the ordered pairs? In order to have a linear function, there has to be a constant slope, a constant rate of change between the ordered pairs. Let's see if it has a constant rate of change. When x changes by 2 units, the value of y is changing by 5 units. The ratio of change in y to change in x is 5/2. From this ordered pair to the next, the value of x is increasing by 2, and the value of y is increasing by 5. The ratio again is 5:2. From 8 to 10, the value of x is changing by 2, and from 20 to 25, the value of y is changing by 5. Once again, the ratio of change in y to change in x is 5/2. There is a constant rate of change, so yes, this is a linear function. Question B, what is its slope? Slope is the change in y over the change in x, so it is 5/2. Question C, is this linear function a direct variation? To be a direct variation, the y-intercept must be 0. So let's figure out what is the value of y when x is 0. Earlier this year, we learned the point slope formula, which is y minus y1 equals m times x minus x1. We can use this ordered pair as our x1 and y1. Let's substitute the values. Now transform this equation so it's in slope-intercept form. First step, distributive property. 5/2 times x is 5/2 x, and 5/2 times -4 is -10. Now add 10 to both sides. And we do get a y-intercept of 0. So in question C, we can answer this question, yes, this is a direct variation. Let's summarize the lesson. We connected our concept of function to the concept of linear equations from earlier this year. One type of linear function is a direct variation. In a direct variation, the value of y is 0 when x is 0.